Hello friends. So now we have very important concept of EIGRP, that is EIGRP metric, or you can say EIGRP metric calculation. So EIGRP metric is based on the metric parameters. So EIGRP use two parameters basically for its calculation. One is bandwidth and second one is delay. So EIGRP metric formula is because this formula is used by EIGRP algorithm to calculate the best route. So as we have discussed, least is the cost or metric value, best is the route. So we will discuss that particular formula calculation. So EIGRP metric is equal to 256 into bandwidth plus delay. Bandwidth plus a delay. But where bandwidth is equal to 10 raised to power 7 upon least bandwidth in kbps, and delay is equal to sum of all the delays, in microseconds by 10. So these two formulas are used to calculate the bandwidth and delay. After calculating these bandwidth and delay calculations, then we can put into the real formula, that is 256 into bandwidth plus delay. So to understand this concept, we have to also understand the k values used by EIGRP. So this is a basically default EIGRP metric calculation formula, and in default metric calculation formula, the k values are fixed and they are by default like this. K1 is equal to 1, K2 is equal to 0, K3 is equal to 1, K4 is equal to 0, and K5 is equal to again 0. So these are the default K fixed values. So when your EIGRP has these fixed values, then it use the default EIGRP metric formula, that is 256 into bandwidth plus delay. So to understand this again, we can take a practical example. Suppose your network scenario is like this. We are creating two routes between any source and destination. So suppose this is our first route. You can say route number 1, and this is our second route, and here we have source and here we have destination. So this is the situation basically. So we will calculate the real practical scenario values with this formula, then we will see at the last how your EIGRP selects the best route to forward the traffic based on this EIGRP metric formula. So here suppose I am taking an example. On the first route, from this router to this router, suppose we have a bandwidth of 1 Gbps, and from second router to third router we have bandwidth of 2 Gbps, and from third router to last router we have a bandwidth of suppose 3 Gbps. Then we have delay of 1000 microsecond between first router and second router on first route. Then we have 1000 microsecond delay on this route, and here again we have 1000 microsecond delay, but I am taking the first delay now. Suppose this is 2000 microsecond because it has less bandwidth. So here we have 2000 microsecond, next we have 1000 microsecond, and next we have 1000 microsecond delay on first route. This is the situation of first route. So according to this formula, firstly we will calculate the default EIGRP metric value, or you can say cost of first route. So here we have first route. So on first route we have to calculate the bandwidth. As you know, we have the formula that is 10 raised to power 7 upon least bandwidth in kbps. So least bandwidth in kbps means we have 3 different bandwidths. First we have 1 Gbps, next we have 2 Gbps, next we have 3 Gbps. So from these 3 different bandwidths, we have the 1 Gbps is the least bandwidth between source and destination on first route. So least is the bandwidth means 1 Gbps is the least bandwidth between 3 bandwidths. So we have to take 1 Gbps as the least bandwidth. But we have to convert this into kbps firstly. So it will be like this. 10 raised to power 7 means upon least bandwidth in GPS. So means 1 Gbps will become 1,000,000 kbps. So it means 6 zeros cancelled out. Then the bandwidth value of first route comes 10. Now we have to calculate the delay of first route. So as you know the formula of delay, that is sum of all the delays in microseconds by 10. So on to first route we have 3 delays, 2000 microsecond, 1000 microsecond and 1000 microsecond. It means sum of all the delays means 2000 plus 1000 plus 1000 upon 10. So it comes 4000 upon 10 cancelled out. So delay value on first root is 400. So we have to put these two values into this formula to calculate the default metric value or cost on first root. So by using these two parameters, we have the formula that is 256 into bandwidth plus delay for first root. So it means 256 into, we have the bandwidth value that is 10 and delay value is 400, like this. Then 10 plus 400 means 410 and it is multiplied by 256 and it comes 104,960 after calculations. So this is the exact EIGRP metric value, or you can say cost for first root. Now we have to calculate this all for second root. So suppose here in this scenario on second root we have a bandwidth of suppose 2 Gbps between first router and second router. Then we have 3 Gbps between second router and third router and 4 Gbps between third router and last router. And the delays on second root are like this. Suppose that remains same. Suppose here we have 2000 microsecond. Here we have 1000 microsecond. And here again suppose we have 1000 microseconds. So according to these parameters, now we have to calculate the bandwidth and delay for second root. So again bandwidth formula is 10 raised to power 7 upon least bandwidth in kps. So it means upon least bandwidth. So first we have 2 Gbps, then we have 3 Gbps and third we have 4 Gbps. So least from these three bandwidths we have 2. So we have to take 2 Gbps bandwidth but in kbps. So in kbps it comes like this, 6 zeros cancelled out, then 10 upon 2 means 5. So it means bandwidth value for second root is 5. So now we have to calculate the delay for second root, and again you know the formula very well. It is sum of all the delays by 10. So sum of all the delays for second root means 2000 microsecond, 1000 microsecond and 1000 microseconds. So again we have to calculate like this, 2000 plus 1000 plus 1000 upon 10. So it again comes 4000 upon 10, that means 400. So this 400 is the value of delay for second root. So now according to these two parameters, again we have to calculate the metric value or cost for second root. So again, as you know, the formula is 256 into bandwidth plus delay. So means 256 into bandwidth value is 5 and delay is 400. So it means after calculating this, 405 multiplied by 256, it comes 103680. So it means 103680 is the default EIGRP metric value or cost of second route. So on first route, we have a cost or metric value of 104960, and on second route we have a cost or metric value of 103680. After comparing these two costs, it means we have the least cost on second route, and on first route we have the higher cost value. So as you know the formula, least is the cost, least is the cost, best is the route, best is the route. So it means according to this formula, second route cost is least as compared to first route cost. So your source router will choose the second route for forwarding the traffic to this destination because this is the best route, and first route is not used by the router to forward the traffic. So second route is the best. So that's it. This is how EIGRP calculate the best route selections according to the default metric formula as we have discussed into this practical example. So in next video or class, we will implement this metric formula calculation on live practical. So thank you so much.